Hey everyone, welcome back to the channel Code with AKJ. Today is day 42 of solving Geeks for Geeks problem of the day, and today's question is rooftop. So the question says here, you are given the heights of consecutive buildings. You can move from the roof of a building to the roof of the next adjacent building. You need to find the maximum number of consecutive steps you can put forward such that you gain an increase in altitude with each step. So in this video, we'll be covering both brute force and optimal solution. So let's get started. So coming to this example input array where the heights of the buildings are given in the form of array. Here we can observe that to move from first building to second building, as there is an increase in altitude, we need to take a step here. So when it comes to second building to third building, since the heights are same, we don't need any steps here. So the consecutive steps becomes 0. So since we need consecutive steps, we can make it as 0 in this case. And when we try from third building to fourth building, as there's an increase in altitude, we'll need a step here. So in this case, the maximum consecutive steps with an increase in gain in altitude would be 1, as the cases would be 1 and 2 and 2 and 3. So coming to the second example, 1, 2, 3, 4, when we try to move from first building to second building, we need a step as there is an increase in altitude here. So when we try to move from second building to third building, since there's again a increase in altitude, we'll need another step. Same goes with the third building to fourth building where there's an increase in height. So we need a step in this case also. So here the consecutive steps would be 3, and they are expecting us to complete this problem in O of n time complexity, and space complexity should be O of 1. So let's start with the brute force approach. The idea here is to check every pair of consecutive buildings, and we'll also take a variable max steps which will help us to track the consecutive steps taken for every moving of one building to another building. So we'll check every pair of buildings and we'll loop through these pair of adjacent buildings. If the next building is taller, we'll increase our current step, and if it is not, we'll reset our current steps to 0 as we need the consecutive steps. So after the loop ends, the variable max steps will hold our maximum number of consecutive steps with an increase in altitude. So here the time complexity would be O of n square, as we are using 2 for loops and checking each and every pair of buildings and comparing their heights. And space complexity would be O of 1, as we are not using any external space. So let's try to code this approach and let's see whether it gets accepted or not. So this is a code for the brute force approach we have discussed, and here I have taken the size of an array. I have taken the max steps which will hold our consecutive steps, and I've used 2 for loops to compare each and every pair of buildings and their height. So if the height of the next building is taller than the current height of the building, then we'll increase our current steps, and if not, we'll move on with the other buildings. So after completing this for loop and checking each and every building with the current building, we'll update our max step and we'll finally return this max step. So let's compile and run this approach. So let's submit. As you can see, this problem got accepted successfully, but it is not meeting our expected time complexity. So let's try to optimize this approach and complete this problem in our expected time complexity, which is O of n. So while this approach and solution works, it's not efficient for large arrays. So let's now talk about the optimal approach. So in the optimal solution, we can do this in a single pass by simply keeping track of the number of consecutive increasing steps as we traverse the array. And if the current building is taller than the previous one, we increment our step count, and if not, we'll reset the count. And we'll also keep track of the maximum steps during this process. Idea here is that we'll initialize a variable max step and current step, which will be initially 0, and loop through this array and check if each consecutive building is taller than the previous one. So if yes, we'll increment the counter and we'll update the max, and if not, we'll reset our current steps to 0. So after each step, we'll update our maximum step if current step is greater. So finally, we'll return max steps. Here's dry run for these 2 examples. Here we'll compare in a single iteration. We'll compare it with the next building, since the next building is taller than the previous. So we'll update our current step with 1 and we'll update our max step. And when it comes to second and third, Since they are same in height, we'll reset our current to 0 and our max remains the same. And coming to the second to third, since the next building is taller than the previous, we'll update our current step with 1 and we'll update our max, which would be 1. And coming to the last two buildings, since they are lesser, so our current steps would reset to 0 and finally our answer would be 1 in this case. Coming to the second example, when we compare this 1 to 2, then 2 is greater than 1, so our current step would be 1 and maximum steps would be 1. And from second building to third building, the third building is taller than the previous building, so we'll update our current step from 1 to 2 and we'll update our max steps from 1 to 2. Same goes with third and fourth. We'll update our current step from 2 to 3 and finally our maximum steps would be 3. So in this case, our answer would be 3. Here the time complexity would be O of n as we are using a single iteration and checking each and every building, and space complexity would be O of 1 as we are not using any external data structure. In this way, we have tackled this problem in our expected time complexity and space. So here is the code for the optimal approach we have discussed through these two examples. So here I have taken the size of an array and maximum step value, which would be initially int min, and current step or count, which would be initially 0. So I've iterated over this array of heights and I've compared these two buildings' heights. So if the next building is taller than the previous one, we'll increment the count or the current step value. So if not, we'll reset its value to 0 and finally we'll update our maximum steps value. And after finishing and comparing all these heights of the building, we'll return our maximum value, which will hold our maximum consecutive steps. So let's try to compile and run this. So let's submit. So as you can see, this problem got accepted successfully and we have solved this problem in our expected time complexity and space complexity, which is O of n and O of 1. And there you have it. We have solved the problem using both a brute force and an optimal approach. The optimal approach significantly improves performance, especially with larger data sets. If you found this video helpful, don't forget to like, share and subscribe to the channel for more daily coding solutions. Let me know in the comments if you have any queries or if there's a specific problem you would like me to cover next. And thank you for watching. I'll see you in the next one.